Good morning to all of you. So, in earlier class, we discussed about the single phase semi-control converter pad DC separately excited motor drive. Yes. So, the single phase semi-control converter pad DC separately excited drive has certain drawbacks. So, to avoid those drawbacks, we will go for the single phase fully controlled converter pad DC separately excited motor drive. So let us have a list out what are the drawbacks of the single phase semi-controlled converter pad DC separately excited drive in the sense. So actually it is a single coordinate operation. It is a single coordinate operation. And it will give the only forward motoring. And the reverse lap power flow does not support. So therefore, while using this drive, this is capable to produce only motoring. There is no possibility to have a braking operation. And suppose if you need to implement the braking when alpha exceeds from 90 to 180 degrees, the source side converter does not allow the operation for transferring power from load to the source, resulting the developed energy is to be distributed within the armature resistance and converter, so that there may be a possibility of damage the motor as well as the converter because of no reverse lap power. To avoid this problem, what can you do in the sense? We will proceed for the single phase fully controlled converter pad DC separately excited drive. This has an ability to avoid the drawbacks in the single phase semi-controlled converter pad DC separately excited drive. So this is the reason we are coming to the single phase fully controlled converter pad DC separately excited drive. Yes. So let us see here. Yes. So this one is single phase fully controlled converter pad DC separately excited motor drive. Yes. So as usually, after keeping the side heading like this, and you can give a statement like this: the single phase fully controlled converter pad converter feeds an armature circuit and its coordinate operation as shown. So this after this statement, you have the circuit diagram. Yes. So the circuit diagram is major drive operation. So for example, this question is given for a 10 marks. Yes. Out of 10 marks, at least 4 to 5 marks is exclusively for the drive circuit based upon the heading. So therefore, you should neatly draw the circuit diagram. So it is a fully controlled converter. In earlier, it was semi-controlled converter, but now it is a fully controlled. Fully controlled converter in the sense all the switches are control switches. All the switches are control switches. But in earlier case, we are using 2 thyristors and 2 diodes. But in this case particularly, all the switches are the control switches. Yes. So you see here, the supply as usually giving to the single phase fully controlled bridge converter. Bridge converter, every single phase fully controlled bridge converter has 2 legs. Each leg has 2 devices, 2 switches. So this is the first switch, this is the second switch. So there are 2 upper switches, 2 lower switches. So you may give the numbering T1, T2, T1, T2 on upper side, T3, T4 on lower side, no problem. Yes. Otherwise, sometimes odd numbers may be represented on the upper side, even numbers may be represented on the lower side. So whatever may be you have to give the numbering. This is the T1, this is the T2, this is the T3, this is the T4. Yes, T1, T2, T3, T4. Yes. So the AC is to be converted into DC. AC is to be converted into DC, and the DC is fed or feed to the the separately excited DC motor. Yes. So it is the separately excited motor. The excitation is to be supplied externally through external supply. Yes. So here also same thing. The AC supply is to be converted into DC and fed to the field winding, because if field control is necessary, field is fed from a control converter. If it is not required, we can directly give to the supply, DC supply. Yes. So in this circuit, as usually, during the positive half cycle, this T1 and T3 is functioning. During the negative half cycle, T2 and T4 is functioning. So this cross, T1, T3 is operates in the first half cycle. T2 and T4 operates in the next half cycle. This, so all the parameters, source voltage, source current, and armature voltage, armature current, A1, A2 is the terminals of the armature, armature inductance, armature resistance. Similarly, you come to the field circuit, source voltage to the field circuit, source current to the field circuit. This one is the field current which is passing through the field winding, having a parameters of field inductance as well as the field resistance. And F1, F2 represents the field terminals. Yes. So, and what's the speciality of this drive as compared to that of the previous drive? That is the single phase semi-control converter for DC separately excited motor. The speciality here is this has an ability to allow the power flow from source to the load as well as load to the source. In earlier converter, due to the diodes, it is not possible to transfer power from load to the source. But the diodes are replaced by thyristors, so definitely it will support the operation of inversion. Inversion are energy transfer from source to the load. That is the rectification. Inversion in the sense load to the source. Yes. So this this is the special advantage of this particular system. So you can draw the coordinate operation. You can draw the coordinate operation. This is a two-coordinate converter. Two-coordinate converter. So as long as the power is transferred from source to the load, VA and IA both are positive, and it will give the first coordinate operation. It will give the first coordinate operation. Yes. So similarly, when the power flows from load to the source, when the supply voltage is reverses, obviously the armature voltage is to be reversed. So VA is to be reversed in the sense the machine acts as a generator and produce the electric power. This power is transferred from load to the source. Yes. So the power is transferred from load to the source, resulting the average output voltage is negative and current is in the same direction. You see here during the supply reverse, the power flow, this is the positive at that time, this is the phase at that time. The power flow is coming from this channel. Yes. So there is no change in the direction of the current. There is no change in the direction of the current for positive half cycle to negative half cycle, but the voltage has to be changed. Voltage has to be changed, and current does not change, so that the reversal of power flow is to be taking place. This will give the fourth coordinate operation. Yes. So what is the first coordinate operation? It is the forward motoring, and this one is the reverse braking operation. Reverse forward motoring, forward braking, reverse motoring, and reverse braking. There are 4 coordinates in the drive system. Yes. So this drive has an ability to give the forward motoring as well as a reverse braking. Yes. So this one is the drive circuit, and this one is the coordinate operation. Yes. And this represents this figure represents the single phase fully controlled converter pad DC separately excited drive. So you remember, students, so the type of question asked is a semi-control converter or fully controlled converter. You can take the clarity. Yes. And then you have to be draw for semi-controller 2 diodes and 2 thyristors. For fully controlled converters, all switches are thyristors. Yes. So during the paper correction, I observed so many times for semi-controlled, some of the students draw the fully controlled and fully controlled by their draw the semi-controlled. So you remember all of you. So you avoid that problem. You can take the clarity from the question. It is a semi-controlled converter or fully controlled converter, and based upon the question, you have to represent the system. And the drive is a separately excited motor or series motor. And fully controlled, all fully controlled converters are two-coordinate converters. Two-coordinate converters. Yes, it has an ability to give the forward motoring as well as the reverse braking operation. Yes. Yes. So what is the description of the circuit? So after side rating and the first statement, and then the drive circuit and coordinate operation. So before going into the principle of operation in continuous conduction mode, you have to describe what is the description of the circuit. So description of the circuit, what we have to do, right? So the single phase fully controlled converter FET, this is separately excited, right? And its coordinate operation as shown. So the armature is feeding the single phase fully controlled converter FET converter. So it has a 4 switches. All are thyristors, and T1, T3 operating in the positive half cycle, and T3, T4 operating in the negative half cycle. Yes. So similarly, the field circuit also see here. The field is also supplied through a converter. If field control is necessary, field is fed from a control converter. Otherwise, you can keep for a uncontrolled converter. It's the other uncontrolled converter. Otherwise, a direct supply. Yes. So this is the description, and then after completion of the description, then you can explain the principle of operation with support of the waveforms in continuous conduction. So let us move for the principle of operation in continuous conduction mode. Yes. So let the supply voltage is defined as, so this is the supply voltage. It is a single phase supply. So Vs is equal to Vm sin omega t. Already we discussed in the earlier class. Vs is equal to Vm sin omega t. It is a AC supply. It should have a both magnitude as well as the phase. Yes. So Vm is the maximum allowable voltage, and sin omega t is the phase of the supply. Yes. So let us see the waveforms of the circuit. And once you understand these waveforms, then it is very easier for clear for us. Yes. So you see here, as usually the supply it is AC supply. This is the magnitude of Vm. The maximum magnitude is Vm. Okay. The AC supply as usually we are taking for 2 cycles. So 0, 5, 2 pi, 3 pi, 4 pi. Yes. So this is a sinusoidal supply. Sinusoidal supply. So this supply has to be changed into unidirectional supply. This supply has to be changed into unidirectional supply or DC supply. So how it is possible in a sense? It will help a fully controlled converter. So fully controlled converter have a 4 switches, and all the 4 switches are a control switches, so that you can give the sequence of pulses for T1, T3 at the first instant, and T2, T4 in the second instant. Yes. So T1, T3 are the odd numbers. T1, T3 are odd numbers. T2, T4 are even numbers. Yes. So during the positive half cycle, one thyristor in the upper set, another thyristor in lower set. So therefore, we are giving triggering pulse for the T1 and T3 at the instant of alpha. At the instant of alpha. So therefore, the source voltage is equal to load voltage. Source voltage, the entire source voltage will be appeared across the load. Yes. So this is the waveform. So it is commenced at alpha, and so you better to draw this waveform similar to the input waveform. This is not the right method to draw. Yes. So the waveform is increasing up to now. It is up to now. It is cutting at the alpha instant, and there onwards it is increasing like this, and goes to maximum value and then comes to here. Yes. So this operation is to be taking place. This operation is to be taking place from alpha to pi. Alpha to pi. Yes. So the average output voltage at pi is equal to almost 0. Yes. So the current is also commensurate pi, commensurate to alpha, and it will be continuing like this. So at the instant of pi, the supply voltage has to be reversed. The supply voltage has to be reversed. Yes. So if the supply voltage has to be reversed, the T1 is and T3 still now conduction. When the supply voltage has to be reversed, it changes the generated EMF so that the motor works as a generator. And producing the electrical energy. And producing the electrical energy in the same path. Producing the electrical energy in the generator and transferring to the source in the reverse direction. When the supply voltage has to be changes, what will happen? The average output voltage is negative. The average output voltage goes to negative, but the current does not change. It will still flow from the source to the load. Yes. So therefore, after phi, the average output voltage is negative, and this will continue the conduction until the next thyristor, next pair of thyristors are coming to conduction. But in case of the semi-control converter, right, at the instant of pi, the average output voltage is 0 because the reverse law power flow does not support the semi-control converter. So that is the reason the average output voltage should 0 at pi. But here converter is a fully controlled converter. When the supply voltage is reversed, the drive has an ability to serve the power from load to the source also. So the average output voltage is negative. The average output voltage is negative when the operation change from motoring to braking, and the generator develops electrical energy, which is transferred to the source in the negative VA and positive I. Okay? So that is the reason we are representing average output voltage is a negative value and current is a positive. Value. And this is taking place until the next pair of thyristors, which are to be triggered at the instant of pi plus alpha. Yes. So at the instant of pi plus alpha, the T2 and T4 will come into conduction, and this process will be still remains going on up to 2 pi plus alpha. So this is similar to that of the first one. Yes. So here you can observe here the current commences at the alpha, and it is passing from source to the load, and even the supply voltage has to be comes to negative value. The current still maintains a positive, so that in both two coordinate converters, first coordinate current is positive, voltage is positive. In fourth coordinate, current is positive, voltage is negative. Yes. So the reverse law power flow is to be taking place from motor to the source. This operation is known as the inversion operation. What is the drawback of semi-control converter? This operation is not getting in case of the semi-control converter drive. So in fully controlled converter drive, it is possible to have the reverse law power flow. So like that, this operation will continue remains. Yes. So the current you are taking, current is always positive. Yes. So the number of sequence of switches are continuously repeating, and the same voltage waveform will be arises for us. Yes. So supply voltage, already we talking about the supply voltage in earlier drive. So the supply voltage is a positive sinusoidal voltage, but the current should be negative one. The current should be a negative one. Sorry, the current should be this one is a sinusoidal one. The current should be a square wave. Yes. So square wave, as usually at the instant of alpha, you are giving a triggering pulse so that the source current is passing from source to the load. So how long it will be passing the current? From alpha to 5 plus alpha, the current will be flow from source to the load. And 5 plus alpha to 2 pi, again the T2 and T4 are taking place so that the source current is continuously flowing from positive source to the load in positive direction as well as the negative direction. Yes. So this is the waveforms. This is the waveforms. Yes. So let us describe the operation. Let us describe the operation of the drive with the help of the principle of operation. So during positive half cycle, at omega t equal to alpha, the thyristors T1 and T2 conducts are T3. You have to be change this one. It is better to odd numbers for positive half and even numbers for negative half. Yes. So T1 and T3 conducts, and the average output voltage VA is equal to VS up to 5 plus alpha. Yes. So the conduction interval here is a alpha to 5 plus alpha. And therefore VA is equal to VS, and VS can be also written as IA RA plus LA DIA by DT plus EB. This is the interval alpha less than or equal to omega t less than or equal to 5 plus alpha. This is the equation number 2. Supply voltage is the equation number 1, and positive operation is the equation number 2. During the 5 to 5 plus alpha, some of the motor generated energy is fed back to the source. Yes. This makes the reversal of power flow. As the converter is a fully controlled converter, it supports the reversal of power flow. Therefore, from 5 plus alpha to 2 pi, 5 to 5 plus alpha, some of the generated energy which is fed back to the source, and makes the reversal of power flow. Yes. So therefore, when alpha exceeds the 90 degrees, the average output voltage is positive. Average output voltage, alpha exceeds alpha greater than 90, the average output voltage is negative. So as per the fully controlled converter equation, 2Vm by pi cos alpha. 2Vm by pi cos alpha is the average output voltage that we are going to be deriving later. So alpha greater than 90, the average output voltage is negative. Yes. So that means that it has a range of the firing angle from 0 to 180 degrees. It is to be split into two intervals, 0 to 91 interval, 90 to 180 another. So less than 90, the average output voltage is positive. Greater than 90, the average output voltage is negative. And the machine or motor behaves as a generator, and this operation is known as the inversion operation. Yes. So this is in detail of the principle of operation. So let us have the average motor terminal voltage. So let us define the average motor terminal voltage. Here the conduction interval from alpha to 5 plus alpha. Beyond that, there is no other conduction. So VA is equal to average voltage is always taking per half cycle. If it is taking per full cycle, it is equal to 0. That is the reason average output voltage is taking per only half cycle. 1 by pi integral alpha to 5 plus alpha Vm sin omega t. Yes. So therefore, you have to simplify this one. And integrate the sin omega t. Sin omega t is the minus cos omega t. So substitute the 5 plus alpha and alpha limit so that it is the Vm by pi to cos alpha. Otherwise, you have to be simplify this equation as a VA is equal to 2Vm by pi cos alpha is the average motor terminal voltage equation of a single phase fully controlled converter fed DC separately excited drive. Even series motor also the same equation. Yes. So because the interval does not change, and the steady state speed is given by already the steady state speed is known. N is equal to VA minus IA RA by K pi. So this one is you should remember all of you. This is a divided by, and this one is a numerator. You can split into number of terms. So VA already just now we are derived, which is the 2 Vm by pi cos alpha. 2 Vm by pi cos alpha is the VA minus IA RA by K pi. Yes. So already this is the steady state speed. For obtaining the speed torque characteristics, this equation is in terms of the speed versus torque. But it is speed is mechanical parameter, current is electrical parameter. So with help of the basic relations, you have to be changed current as a torque. Yes. So the average speed can be expressed as, you see here, the average speed N is equal to, the average speed N is equal to 2 Vm by pi cos alpha. Why? Because as usual VA is substituted here, 2 Vm by pi cos alpha divided by K pi minus, in the previous equation, previous drive we are discussed, IA is equal to T by K pi. T by K pi. So T by K pi whole square, RA into T by K pi whole square. This is the average speed in terms of the speed at torque. Yes. So based upon this equation, you have to draw the speed torque characteristics. Speed torque characteristics. Yes. So the speed torque characteristics as shown. See here. This is the speed torque characteristics. So in this speed torque characteristics, as usually, based upon the coordinate operation, the speed torque characteristics are drawn here. So it is the speed versus torque. Speed versus torque. Yes. So it is a how many coordinate converter? 2 coordinate converter. One is the first coordinate, another one is the fourth coordinate. So first coordinate is known as the forward motoring. Fourth coordinate is known as the reverse braking. Reverse braking. So these values Vm by K, 2 Vm by pi K is the no load speeds. No load speeds. So the speed torque characteristics as shown. The ideal no load operation is obtained. The ideal no load operation is obtained when IA is equal to 0. Yes. So when IA is equal to 0, then both thyristor pairs are peeled to pi. When alpha is less than 90 degrees, EB is greater than or equal to Vm, and alpha is greater than pi by 2. EB is greater than or equal to Vm sin omega t. Vm as well as Vm sin omega t. Okay. So you see the no load speeds which are getting by substituting IA is equal to 0 in the equation. And the speed equation consisting of a cos alpha term. So you are giving different values of alpha, different values of alpha. So the characteristics are represented here. Yes. So the characteristics are commenced from no load speed to like this. Yes. So alpha is equal to 0, alpha is equal to 60, alpha is equal to 90. So that means that before 90, the characteristics occupies in the first coordinate, and above 90, the characteristics occupies in the fourth quadrant. That is the reverse braking operation. Up to 90, it is the motoring operation. Beyond 90, it is the braking operation. Yes. So already I told that in the speed torque characteristics of single phase semi-control converter, this dotted line represents the boundary between continuous and discontinuous conduction. So continuous conduction, the currents are very smooth, the characteristics are very constant nature. So that's why the right side of the dotted line, you have to be observed all the characteristics which are very smooth in nature, So that's why this conduction is known as the continuous conduction. And whereas you can observe the left side of this dotted line, all are very drastically varying. Yes. So for a small change of the torque, how the speed is to be drastically changing. So that is the reason this dynamics or this operation is to be termed as the discontinuous conduction. Yes. So you can differentiate the continuous conduction waveforms as well as the discontinuous conduction waveform, so that the boundary between continuous and discontinuous conduction is to be achieved. That is to be decided by the critical speed. Already I told that in the earlier slide. Yes. So speed torque characteristics of single phase fully controlled rectifier fed DC separately excited motor. See, the coordinate operation while beginning we are given. Yes. So it is a single phase fully controlled rectifier which occupies in the forward motoring in first coordinate before 90. After 90, it occupies in the fourth coordinate, which is the reverse braking operation. Yes. So what we discussed that is to be kept here. The boundary between continuous and discontinuous conduction is to be shown in it will be a dotted line. But torque less than the rated is the torque less than the rated torque. A low power drive mainly operates in discontinuous conduction, makes speed regulation very poor. Yes. So in low power ratings, see the torque less than the rated torque, at the time it operates in a discontinuous conduction operation, so that the speed regulation is very poor. Yes, that's why discontinuous, we are not preparing discontinuous conduction. The drive operates in discontinuous conduction mode. Resulting, what will happen? The drive performance is reduces, and similarly the lifetime of the drive is reduces. So that's why we are giving the much importance for continuous conduction, where the smooth speed control is acceptable and good speed regulation is also available in the continuous conduction. Yes. So in continuous conduction, speed torque lines are parallel straight lines. So as per this characteristics, what we observed that during the continuous conduction, the waveforms are almost similar to that of as parallel straight lines. But in discontinuous conduction, you can observe the drastic variation of the characteristics. Yes. So this is the speed torque characteristics of single phase fully controlled rectifier fed DC separately excited motor. And one more thing, how this drive has an ability to allow in the first quadrant and fourth quadrant, that should be explained with support of the VA versus alpha curve and the motoring and braking operation. That's also we are going to be discussed here. See, the VA versus alpha curve. So VA versus alpha. Alpha has a range of 0, pi by 2, and pi is 0 to 180 degrees. Is so what is the average output voltage? Average output voltage is 2 Vm by cos alpha. So cos alpha is equal to 0 in the sense cos 0 is 1. So therefore, what is the maximum voltage available for us is 2 Vm by pi. 2 Vm by pi. So average output voltage is a 2 Vm by pi cos alpha. But cos alpha is equal to 0 means it is 1. The maximum voltage available for us is a 2 Vm by pi. Yes. So there onwards, you are increasing the firing angle from 0 to 90 degrees. How the average output voltage is gradually decreases and comes to be 0 at the instant of pi. Sorry, at the instant of pi by 2. And beyond pi by 2, the average output voltage, you can substitute 91 degrees. Yes. So 91 onwards, 90 it is 0, 91 onwards, the average output voltage become negative. Yes. So 90 to 180 degrees, the average output voltage is going to be increase in the negative side, negative direction. And then at the instant of pi, it reaches to the maximum negative voltage of 2 Vm by pi. Yes. So in earlier VA versus alpha curve for separately excited motor, even you are varying from 0 to 180 degrees also, the characteristics occupies in the only positive side, but there is no negative side. So this characteristic supports for us for our explanation. This drive has an ability to allow the forward motoring as well as reverse braking operation. Yes. So the VA versus alpha curve and two coordinate operation, the VA versus alpha curve and two coordinate operation, the forward motoring and braking as shown. Is so in coordinate 1, you see here omega m speed is positive and alpha is less than or equal to 90. And the polarities of VA and E as shown. Is so after VA versus alpha curve, we have also look on the fully controlled rectifier towards the operation is going. So if alpha is equal to less than 90, alpha is equal to less than 90. So the average output voltage, average output current, both of a separately excited motor, both are positive, and the speed is also positive. Omega m greater than 0. It is the more than 0. That means the speeds are positive. Yes. So if alpha is less than 0, omega m greater than 0, and you see that the supply and converter, fully controlled converter, it is the polarities are plus and minus. So the motor side also polarities are coincides with the supply. This is the plus and minus. So therefore the power flow flows from source to the load in this direction. Yes, the direction of the armature current you can observe is the AC power is converted in DC. This is the positive polarity, this is the negative polarity, and the power flows through the IA. Power flows through the IA and motor and the negative. Yes. So that means that alpha less than, as long as alpha is less than 0, the speed is positive and the power flows from the motoring to the power flows from the supply to the motor or load. Yes. So this is the operation. This operation is known as the motoring operation. And here the converter is a fully controlled converter. So when the supply voltage is reversed, when the supply voltage is reversed when alpha is greater than 90. Alpha is greater than 90. So as the supply voltage is reversed, so see that the polarity of representation of the polarities. This is the negative, this is the positive. Yes. So, and here the armature is also itself changes the polarities of the supply. So therefore the power flows from motor to the load in this direction. Motor to the load in this direction. It is the armature current direction you can observe in both the circuits. There is no change in the armature current from motoring operation to braking operation. So that's why in first quadrant and fourth quadrant, the current is always positive, but the voltages should be changed from positive direction to negative direction. So here alpha is greater than 0, average output voltage is negative, and the speeds are less than 0. Speeds are less than 0. Speeds are less than 0 in the sense, so what type of speeds? Negative speeds. Negative speeds are to be taking place in the generating operation. So therefore, during the generating operation, it opposes the motion because the machine acts as a generator and produce the braking torque. Yes. So that is the reason this operation is known as the regenerative braking operation, where the energy is transferred from load to the source. In motoring operation, the energy transferred from source to the load, whereas in braking operation, the energy transferred from load to the source. Yes, these are very supportive for explanation of the two coordinate operation of the drive in the first coordinate as well as the fourth coordinate. So what based upon this diagrams, the description is to be very clearly mentioned here. The VA versus alpha curve and two coordinate operation in the forward motoring and regenerative braking as shown. In coordinate 1, omega m is positive and alpha is less than or equal to 90. So the polarities of VA and V as shown, VB as shown. Yes, this is the polarities. So for positive IA, this causes rectifier deliver power to the motor, this giving forward motoring operation. What we discussed theoretically, the same is to be initiated here. So when alpha is less than or equal to 90, speed is positive, and the direction of the VA and EB you can observe. So based upon that, what we can conclude in the sense the power is transferred from source to the load. Yes, this is the motoring operation. Whereas in fourth coordinate operation, what will happen? See the polarities of VA and EB. Yes, in fourth coordinate operation, the polarities are VA and EB and IA as shown. So EB is reversed due to the reversal of speed. Why the reversal of speed is to be taking place? The supply voltage has to be changed, but still the IA maintains the same direction. Still the IA maintains the same direction. Therefore, machine works as a generator and producing braking torque. Yes. So further, alpha greater than 90, VA is negative, then the rectifier takes power from the motor and transfer to the AC source. So this operation is known as the inversion operation. This operation is known as the inversion operation. Yes. So this is the way. This is the way to explain the fully controlled converter FET DC separately excited, right? Yes. So finally, you can conclude that. So the single phase fully controlled converter FET DC separately excited. Yes. So you should draw the circuit diagram and coordinate operation, and followed by the description of the circuit, and then the principle of operation is to be explained in the continuous conduction mode with support of the waveforms, and based upon the discussion, we can derive the average output voltage and steady state speed and the average speed, and based upon that the speed torque, based upon the average speed, we can obtain the speed torque characteristics of single phase fully controlled converter, right? And based upon the speed torque characteristics, we should have a VA versus alpha curve and coordinate operation, forward motoring and forward braking to be explained with support of this. Yes. So this is the single phase fully controlled converter FET, right? So students, with this, I am stopping the presentation. Thank you.